Today, we're talking about point slope form. Y take away y1 equals m times x take away x1. Similar to last day's lesson, m is our slope, which we know quite well by now. X comma y represents all infinite points that are on the line. And this time in the equation, we have x1 comma y1. These represent a very specific point that is on the line. It's going to be our starting point. We'll take a look at a couple of examples and make sure that we understand both how to draw from this version, how to change this version into something else, and how to write an equation in this version. So significant to start with is the fact that x1 and y1 always appear opposite from what we see in the equation. Plus becomes minus, minus becomes plus. Our first example, y minus 3 equals 2 times x minus 4. So you'll notice that the minus 4 and the minus 3 turn into a plus 4 and a plus 3. I start at that point. I use my slope of up 2 over 1. I draw my line, and I'm quite satisfied with it. Again, I started at the 4 comma 3. Please note, I could rearrange this equation using some math. I could multiply the 2 into the brackets, move the 3 to the other side, and come up with a slope-intercept form. And you'll notice that it does go through that minus 5 b value. Example 2. We've got y minus 5 is equal to 2/3 times x plus 3. So that plus 3 is kind of like take away a negative 3, and that's why when we switch the sign, we start at negative 3 comma positive 5. That's my first point. Use my slope up 2 over 3. Draw my line. Please, everyone, make sure that you are drawing your lines from one side of the grid right through to the other. Put arrows on both sides. Again, in the notes here, I rearrange everything and I rewrite it in y equals mx plus b form. And we do find, once again, it is working out exactly like last day's lesson. So why not just always rewrite it in y equals mx plus b form? Well, sometimes that could prove problematic, as in our next example. For this one, we're starting at negative 3 comma negative 2. Our slope is down 1 over 5. Our line looks something like this. And you'll notice that on the y-axis, it's not going right through a nice point. If I try to use some math and rearrange things, I bring in the negative 1/5. Ooh, I get a negative 3/5. I subtract over the 2, which is negative 10/5. Gives me a negative 13/5 as my b value, which is about negative 2.6-ish. So yeah, it did work, but that would not be a nice way to start with y equals mx plus b equation. We can also use this to write the equation based on the graph. So suppose I have a line where I know for sure it goes through 2 comma 1 and negative 5 comma negative 1. I could use either of these points to write the equation with. The first thing I have to establish is, what is my slope? So if I go from one point to the other right here, just writing out the equation, I could plug in the 2 and the 1, and then to find the slope, you'll notice I'm going up 2 over 7, so I write in my slope of 2/7. I could also use the other point and write it out as y plus 1 is equal to, again, I'm going to use that 2/7, x plus 5. Both of these equations are the same line. And I'll demonstrate this by taking both of them and changing them into y equals mx plus b in this next step. So looking at this very, very carefully, we'll notice that we bring the 2/7 in. The fractions aren't the nicest, definitely, but everything does work out quite nicely for this. I get y equals 2/7 x plus 3/7. With the other equation, rearranging it, you'll notice that it comes to the exact same thing, which we totally expected. So that just leaves us with a little bit of work to try and make sure that we're understanding this material all right. It's on page 372. Take your time with it. Be patient with yourself. Use whatever other insights or abilities you need to be able to make sure you're understanding the math. And I do hope that you have some fun with this. I'll talk to you soon. Goodbye.